Hello everyone, I'm Sneha. I'm a third year MBBS student at AIIMS Nagpur, and today in this session we'll be solving previous year questions for the chapter Alternating Currents. 18 questions we have already solved in part 2. This is part 1. This is part 2 of the series, and we'll be starting from question number 19. So question number 19 says that there is a LCR circuit. Right here is a L, which is an inductor, a C, which is a capacitor, and R is a resistance. So this is an LCR circuit, which is connected to a source of alternating current. So we need to know that at resonance, the applied voltage and the current flowing through the circuit, what would be the phase difference between both of these? So we have to find out at resonance. So what is the peculiar feature at resonance? This, if we consider the self-inductance as L, the capacitance as C, and it as R. So at resonance, we have XL, which is the inductive reactance, is equal to XC. So XL is omega L and XC is 1 by omega C. So omega is 1 by LC and omega square is 1 by LC and omega is 1 by under root LC. So what does this actually mean in terms of theory? That at resonance, the circuit is completely resistive. The circuit is completely resistive. Okay. So in a resistive circuit, the phase difference between voltage and current, it is equal to 0. So if we consider, we represent these LCR circuits with the help of this. Okay. So this right here is resistance. This is XL and this is XC. So XL and XC, they cancel out each other. So the circuit is purely resistive. Okay. And in resistance, and in a resistive circuit, we have, if this is the direction of current, the same is the direction of voltage. That is, the phase difference is supposed to be 0. And this right here is option D, which is our answer. Moving on to the next one, they have also given the solution for this particular question, that at resonance, omega L is 1 by omega C. So the circuit behaves as if it contains R only. It contains only the resistor. So phase difference is 0, and at resonance, impedance is maximum. What is impedance? Impedance is represented by Z, which is equal to under root R square plus XL minus XC whole square. So XL is equal to XC. So Z is equal to R. And current in the state, current, which is represented by R, I, current is maximum in resonance. Okay. Moving on to the next one, we have that the time constant of CR circuit. Question number 20. We have to find out the time constant for CR circuit. This is a CR circuit. This is capacitor and this is resistor. So in a CR circuit, we can represent the charge Q at any time as Q naught. Q is equal to Q naught 1 minus e power minus t by CR. And we have the basic formula as time constant is actually, it is represented by this, and Q can be represented as Q naught 1 minus e power minus t by tau. And tau here is time constant, which is equal to CR in this case. Okay. So what do we learn? That time constant in a CR circuit is equal to C multiplied by R. Okay. And this right here is our option C. which is the solution. Okay, moving on to the next one, we have a transformer. So a transformer has efficiency of 90%. So efficiency is what? 90%. And is working on a 200 volt and 3 kilowatt power supply. So we know that transformer has a primary coil and it has a secondary coil. Primary coil is the input and secondary coil is the output. Okay. So input, which is the primary coil, they have given the voltage VP as 200 volts. They have given the PP, which is the power of the primary coil, as 3 into 10 power 3 watt. They have given it as kilowatt. So I've converted that in watt. So it is equal to 3 into 10 power 3 watt. Okay. So if the current in the secondary coil is 6 ampere, so I in secondary is 6 ampere. So we have to find out the voltage across the secondary coil. So Vs is what? Okay. So we'll consider Vs as V only. Okay. So we know that efficiency for a transformer is power delivered at the secondary coil upon power at primary coil. So power we know is equal to Vi. So it can be written as V of secondary coil into I of secondary coil divided by V of primary coil divided by I of primary coil. So efficiency they have given as 90%. So efficiency is 90%. It can be written as 90 by 100. So 90 by 100 is equal to Vs into Is upon Vp into Ip. So for primary, they have directly given a P. So we'll just write it down. So 90 by 100 is equal to Vs, which is V, into current in the secondary coil, it is equal to 6 divided by the power in the primary coil, we have 3 into 10 power 3. Okay. So if we just solve the question, V into 6V is equal to 9 by 10 into 3 into 10 power 3. V is equal to 9 into 3 into 100 divided by 6. 3 to the 6, which is 4.5 into 100, and V is 450 volts. V, which is equal to V in secondary coil, is 450 volt. Now, they've also asked to calculate the value of current in primary coil. So, how do we calculate the current in primary coil? We have been given a power of primary coil as power of primary coil is 3 kilowatts, which is 3 into 10 power 3 watts. So, 3 into 10 power 3 can be written as V of primary coil into I of primary coil. 3 into 1000 is equal to V in primary coil, they've given as 200, and I in primary coil we need to calculate. So I in primary coil can be written as 3 into 1000 divided by 2 into 100. So the value would come out as 15 amperes. So current in primary coil is 15 amperes, and the voltage across the secondary coil, it is 450 volts. So the answer is option number B. Okay. So answer is option number B. Moving on to the next one, we have question number 22, in which they have given that the primary of a transformer, when it is connected to a DC battery of 10 volts. So we have a DC battery of 10 volts, it draws a current of 1 milliampere. The number of turns of primary and secondary windings are, so if we consider N T as the number of turns in primary, so it is equal to 50. and ns as the number of turns in secondary, and it is actually equal to 100. So they have asked us to calculate the voltage in the secondary and the current drawn by the circuit in the secondary, respectively. So if we do not read this question clearly, we'll just jump right into the solution. They have given us NP and NS, and we know NP and NS is the ratio for the voltage. It is in direct relation with the voltage VP and VS. But did we read the question properly? The first line itself says that the primary of a transformer, when it is connected to what? It is not connected to DC battery. It is not connected to AC battery. It is connected to DC battery. All these formulas are applicable when the current is alternating, when it has a phase difference. It goes through different phases. In a DC battery, there is no phase. A transformer is essentially an EC device. DC device shows no mutual inductance between this coil. So, no voltage in secondary coil, no voltage in secondary coil, and no current in secondary coil. Okay. We need to make sure that we are reading the question quite well, because in one word itself, whole question has flipped over and the solution is totally different. So every word we need to read carefully. Okay. Moving on to the next one, we have our question number 23. Question number 23 is that a 220-volt input is supplied to a transformer. So it is our primary coil, primary, and then we have secondary. So primary, we have VT as 220 volts, the output current. So IS is 2 ampere and VS is 440 volt. And they've given the efficiency. We have efficiency is given as 80%. So efficiency for this particular circuit is 80%. And they have given that the current, we have to calculate the current drawn by the primary windings of the transformer. So we have to calculate IP, which we'll take it as I. So we know efficiency is what? Efficiency is power that is derived in secondary coil divided by power of primary coil. Okay. So efficiency is 80%, which can be written as 80 by 100 if we remove the percentage sign. So 80 by 100 is PS by PP. PS can be written as VS into IS upon PP can be written as VP into IP. Okay. So 80 by 100 is actually VS, we have been given as 440, and IS is 2 ampere. So 440 into 2 divided by VP is 220 into I. Okay. So this is 2 times. So 80 by 100 is 2 into 2 by I. Now if we solve this question, so I would be equal to 2 into 2 into 10 divided by 8. So 2 4s are 2 2s are. I comes out as 5.0 ampere. So what is the current drawn by primary windings? It is actually the current drawn by primary winding, right? This is I, and this is which option? This is option D. Okay. Moving on to the next one, we have that the primary and secondary coil of a transformer have 50 and 1500 turns respectively. So again, a transformer based question. We have question number 24. We have a primary and a secondary coil. This is primary, this is secondary. So primary coil, they have given the number of turns is equal to 50 and ns is equal to 1500. And they have given the magnetic flux linked with the primary coil phi is equal to phi s plus 4t, where phi is in Weber's. Okay, so we have to calculate the output voltage. We need to find out Vs. So we know from the previous chapters, from the magnetism unit, that V is actually d phi by dt. So Vp can we write as d by dt of phi s plus 4t. So Vp is d by dt, which comes out to be 4 volt. So Vp we have calculated as what? 4 volt. Okay. Now we need to calculate out Vs. So they have given that they have given us the ratio of number of turns. So this is an important formula right here. That number of turns is actually proportional to the voltage. Okay. So Np by Ns is equal to Vp by Vs. NP they have given as what? Primary they have 50 turns and secondary they have 1500. So 50 by 1500 is equal to VP is what? VP we calculated as 4 and VS we need to calculate. So V is equal to 4 into 1500 divided by 50. Okay. So 4 into 30. So V, which is equal to Vs, is equal to 120 volts. Okay. So what is Vs? It is the output voltage across the secondary coil. So the output voltage across secondary coil. And what is the value of output voltage across secondary coil? It is equal to 120 volts, which is option A. Moving on to the next one, we have question number 25. A transformer is used to light a 100-watt and 110-volt lamp from 220-volt mains. So we have been given as a bulb, which is what it is. Its power is 100 watt and its voltage is 110 volt. So a transformer is used to light this bulb. So this bulb right here is our output. Okay. It is our output or secondary coil. So PS is actually 100 watts and BS is 110 volts. Okay. And what have they given about the primary coil? For primary coil is actually a transformer. And in this, we have VP as 220 volt and the current in the main current, which is the IP, is equal to 0.5 ampere. And what do we need to calculate? We have to calculate the efficiency. So, do we know the formula for efficiency? Efficiency is P output over P input. It is the ratio of the power which we have derived from the ratio to the power that we have given to the system. Okay, so P output is our secondary coil and input is our primary coil. So efficiency is the ratio of power between the primary coil and that of a secondary coil. So R is V into I. So efficiency can further be written as V of secondary into I of secondary upon V of primary into I of primary. V of secondary coil is, we have not been given current in secondary coil. So why do we actually need current if we are already given the power? So it is 100. So 100 divided by V of primary is 220. Just a minute. We have efficiency as power of output upon power of input, which is equal to 100 by P of input is V of primary into I of primary, which is equal to 100 by, in primary we have 220 volts into zero point 0.5. Okay, so this would come out as a fraction. We need it in percentage, so we'll multiply it by 100. So it is equal to 100 divided by 22 into 5 into 100, which is 100 divided by 110 into 100. It would come out as almost zero point 0.9. So it is 0 0.9 into 10, 0 0.9 into 100. So efficiency is what? 90%. Efficiency for this particular system is what? It is 90%. And which option is 90%? So the option number B. Option B is our answer. Okay, moving on to the next one. We have that the core of a transformer is laminated because we have question number 26. So if this is a transformer, it can, what does a transformer actually contains of? It contains of two coils, primary coil and secondary coil. So primary coil is the one through which we are giving input, and secondary coil is the one through which we are giving output, through which we are taking output. Okay. So in a transformer, we usually laminate the core. The core is laminated. Why is the core laminated? Because there is production of eddy currents to the changing fields. So when these eddy currents are produced, they result in energy losses. Okay. So the core is laminated so as to decrease the energy loss, which is due to the eddy currents. Okay. So when there is a change in flux, so we are changing the flux due to which the voltage is changed. So phi is flux and V is d phi by dt. So we are changing the flux in the core of a transformation due to a change in current around it. So current is changing due to which the flux is changing, and eddy currents are produced due to this change in flux. So why are eddy currents produced? Eddy currents are produced due to change in flux. The direction of this current is actually opposite to the current which we produce. So it will reduce the main current. So we laminate the core so that the flux that is reduced, resulting in the reduced production of eddy currents. Okay. Moving on to the next one, we have a transistor oscillator, which is using a resonant circuit with inductor L and capacitor C. So, question number 27, we have this is an LC circuit. This is inductor. This is capacitor. So, L and C. So, they are in a series, and we have to find if they have given us two situations. We have case one And then we have case 2. Okay, so in case 1, when L and C are in series with each other, they produce a frequency F. Now L is doubled. So in this case, we have 2L and C is changed to 4C. So we have to calculate the value of F dash. So do we know that at resonance, we have omega equal to 1 by under root NC, and omega can also be written as 2 pi F. So 2 pi F is 1 by under root LC. So frequency is 1 by 2 pi root LC. Okay, so we will calculate the ratio between frequencies in case 1 and case 2. So F1 is 1 by 2 pi root LC, which is equal to F. F dash is equal to 1 by 2 pi. We have 2L and 4C, which is 1 by 2 pi into 2 root 2 LC. So if we divide, this is first equation and this is second equation. Divide 1 and 2. So F by F dash is equal to 1 by 2 pi root LC into 2 pi into 2 root 2 under root LC. So all of this will cancel out with one another. So F by F dash, F by F dash is 1, 2 root 2. So F dash is what? It is F by 2 root 2. Okay. So the final frequency is 1 by 2 root 2 times that of the initial frequency. So the frequency in this case, it becomes 1 by 2 root 2 times. Okay. So this right here is option B. Moving on to the next one, we have question number 28. Question number 28, we have the current value is 1 by root 2 sine 100 pi t and E, which is the voltage, is 1 by root 2 sine 100 pi t plus pi by 3 volt. Okay. So we have to calculate the average power which is consumed in the circuit. Average power. So average power is actually P is equal to IRMS into VRMS into cos phi, where phi is the phase difference. Okay. So how do we calculate value of IRMS and VRMS? The general representation for current is I is equal to I naught sine omega t, and V is equal to V naught sine omega t plus phi. Okay. So firstly, we can calculate the value of pi as pi by 3, and I naught is equal to 1 by root 2, and V naught is equal to also 1 by root 2. And I RMS is I naught by root 2, whereas V RMS is V naught by root 2. So I RMS comes out as 1 by 2, and V RMS comes out as 1 by 2. So what is the power? Average power. Average power is VRMS into IRMS into cos phi, which is equal to 1 by 2 into 1 by 2 into cos pi by 3, which is equal to 1 by 2 into 1 by 2 into 1 by 2 equals as 1 by 8. So what is the average power in this case? Average power is 1 by 8 watts. Okay. Moving on to the next question, which is question number 29. We have a step up transformer which operates on a 230-watt line, 230-volt line, and supplies a load of 2 ampere. So the ratio of primary and secondary windings is 1 is to 25. We need to calculate the current in the primary coil. So primary coil and secondary coil. Primary coil VP is 230 volt, and I in primary coil we need to find out which is I. In secondary coil we have IS as 2 ampere. B we do not know. We have the number of NP by NS as 1 is to 25. So did we read the formula where we told that number of the windings is actually directly proportional to the voltage? So NP by NS is actually equal to VP by VS. So 1 by 25. VP we have been given as 230 and VS is V. So VS 230 into 25. Okay. So this value we have. Now the power across both of this should be same because we are considering that the efficiency is 100%. So P in primary is P in secondary. So primary power in primary is VP into IP, which is equal to VS into IS. VP is what? VP is 230 into I we need to find out. VS is 230 into 25. We just calculated it here. Into I is 2 ampere. So I can be written down as 230 into 25 into 2 divided by 230. So current can be written as I, which is equal to 25 into 2. I can be written as 50 ampere. Okay. So what is I? It is the current in primary coil. So current in primary coil, it is equal to 50 ampere, which is option B. Next, we have the next question. And also they have written as that NS by NP, number of coils in secondary by number of coils in primary is VS by VP. We know that. And this is also given as a ratio, which is equal to K. K is what? K is our transformation ratio. We have two types of transformers. So transformer is of two types. We have a step up transformer and a step down. So in step up transformer, K is greater than 1, and in a step down transformer, K is less than 1. What does K greater than 1 means? That the number of turns in secondary is greater than that of primary. And in this, secondary is less than primary. Okay. So moving on to the next one, we have question number 30. The primary winding of a transformer has 500 turns, whereas secondary has 5,000 turns. So primary N3 is equal to 500 and NS is equal to 5,000. So the primary is connected to an AC supply of 20 volts and 50 hertz. So VP is equal to 20 volts and frequency in primary is equal to 50 hertz. So we have to calculate Vs is what and Fs is what. This is the question. Okay. So we know that if we have an AC source, in an AC source, the frequency remains same. Okay. So Fs would necessarily be Fp, which is equal to 50 hertz. We have solved half of the question. Now we need to calculate Vs, which is equal to V. Okay. So uh, we have the ratio of number of turns. So Ns divided by Nt is what? Vs by Vp. So Ns number of turns in secondary is 5000. And I just told you in the previous question that if Ns is greater than Np, it is what? It is a step up transformer. This one is what? Step up. Okay. So Vs in secondary, we have to calculate the voltage, and in primary, we have the voltage as 20. So V is 50 by 5 into 20. So V is 200 volts. Okay. So the second coil has a voltage of what? Has a voltage of 200 volts. And this is an example of which transformer? As Ns is greater than Npr, so K is greater than 1, which is a step up transformer. Okay. So the transformer, it converts a AC high voltage into an AC low voltage, but it does not cause any change in frequency. Okay. So the frequency, this we need to highlight right here, that for a transformer, the frequency, it remains same. Moving on to the next one, we have question number 31, which is related to eddy currents. So when are eddy currents produced? Eddy currents are actually currents which are produced when the magnetic flux changes. And these currents are opposite in direction of the main current, opposite in direction to the main current, due to which they cause loss of currents, loss of energy. Okay. So when is a magnetic flux produced? Magnetic flux is produced when a metal, it is kept in a varying magnetic field. So magnetic flux is produced when a metal, it is placed in a varying magnetic field. Okay. And how can we reduce eddy currents? How do we reduce? Why do we need to reduce eddy currents? Because they are opposite to the current that is produced. So they actually cause wastage of the current and the energy as a whole. So we need to reduce eddy currents, and they can be reduced by laminating the core. Okay. So eddy currents, they're produced when a metal, it is kept in a varying magnetic field. Moving on to the next one, we have question number 32, which is E is equal to 200 root 2 sine 100 t volts. Okay, and it is connected to a capacitor. So this right here is a capacitor, and we have connected it to an AC source which has voltage E, which we have represented here. So the capacitor is of capacity C equal to 1 microfarad, which can be written as 10 minus 6 farad. Okay. And we have to calculate the RMS value of current. IRMS is what? So do we know Ohm's law? Ohm's law says that V is equal to IR, I is equal to V by R. But V in this case should be VRMS if we want the current to be IRMS, and R should be equal to Z. So for a capacitor, Z is equal to XC is equal to 1 by omega C. Okay, so E is 200 root 2 sine 100 t. So E for a normal representation, V is V naught sine omega t. So V naught is what? 200 root 2. So V RMS is V naught by root 2, which is equal to 200 volts. And omega in this case is 100. So IRMS is VRMS upon 1 by omega C. IRMS is equal to VRMS into omega C. So VRMS in this case, we calculated it as 200 into omega is 100 and C is 10 power minus 6. So it is 2 into 10 power 4 into 10 power minus 6 is 2 into 10 power minus 2, or we can write it as 0.02 ampere, which can be further written as 20 milliampere. So the RMS value of current, which is IRMS, is equal to 20 milliampere. Okay. Which is our option number D. Okay. Moving on to the next question. We have question number 33. Question number 33, they have given the RMS value of potential difference V, which is given here. Okay, so we have to calculate RMS value. So do you know the full form of RMS? RMS actually means root, mean, and square. So to find out RMS for any particular like quantity, we need to square it. Then we have to take the mean, and then we have to find the root one under root. Okay. So in this case, we have to find the RMS value of potential difference. So V RMS is what? So V RMS is actually under root area under the graph from 0 to t divided by total time. So area under the graph is what? Area under the graph is V naught into t by 2. V naught into t by 2 upon total time is what? T whole square. Okay. So we have t by 2 into V naught square. plus 0 divided by total time is t. So it is equal to t will cancel out. So under root v naught square by 2, which is equal to v naught by under root 2. So the RMS value for voltage in this particular question is v naught by 2. Again, we'll take a look at what we did. We calculate the RMS. So we will go in backward direction. RMS means root, then we have mean, and then we have square. So first we'll square the quantities, then we'll take mean of the quantities, and third we'll take root value. Okay. So in this case, we have this is t by 2, this is t v naught. So we need to find out the average or the RMS value from this point to this point, from 0 to t. So if we take it, so the RMS is under root. We will square the value. It is v naught square, and it is for how much time? It is for t by 2. And in the other half, we do not, the value of potential is 0. And if we take it as the mean, the total time is t. So mean is total value divided by total time. And then we'll put all of this under a square root. Okay. Moving on to the next question. We have question number 34. We have an AC circuit in which EMF and current at any instant are given by E is equal to E naught sine omega t and I is equal to I naught sine omega t minus 5. So it is minus 5. So in this case, the voltage, it leads current by how much value? By a phase difference of 5. By a phase difference of 5. Or in other ways, we can say that the current, it lags behind voltage by a phase difference. Fine. Okay. So we need to calculate. If we draw it in graphical format, so if we draw x-axis and y-axis, this is x-axis, this is y-axis. So actually, E, if we take it as x-axis, so this is E, which is E is E naught sine omega t. E is equal to E naught sine omega t. So current is actually lagging behind. So I is I naught sine omega t minus 5. Okay. Or in other words, if we take I on x-axis, this is x-axis and this is y-axis. So if I is I naught sine omega t minus 5, so this is E, is E naught sine omega t. And this angle right here is 5. Okay. So we have three types of circuit in if we take We have either a capacitor, we either have a resistor, or we can have an inductor. Or we can have all three of them together, which is an LRC circuit. So we can have L, which is inductor, R, which is resistor, and C, which is capacitor. Okay. So this is an inductor, L, this is a capacitor, and this is a resistor. Mostly we have combinations. In this particular chapter, we usually have all of these three in combination. So it can either be an LR circuit in which we have an inductor and a resistor, or we can have a CR circuit, we have a capacitor and a resistor, or we have an LRC circuit, we have all three of them together, L, C, and R, or we can have an LC circuit. Okay. So these are the four type of questions that can be asked. So this is an LR circuit. So in LR circuit, what is the particular feature for an LR circuit? LR circuit, voltage leads current by 90 degree. Okay. In CR circuit, we have capacitor and resistance. We have current which leads voltage by 90 degree. Okay. And LCR circuit, it would be relative. It would depend on the magnitude of resistance of the inductor and the magnitude of resistance of um, our capacitor. So if XL is greater than XC, XL is greater than XC, so voltage will lead. If XC is greater than XL, current would lead. And if XC is XR, it is resonance. So voltage and current would be in phase. Okay. So moving on to this question number 34. We have E is equal to E naught sine omega t and I is equal to I naught sine omega t minus phi. Okay. So if we need to find out the value of average power in these types of circuit, it is given as VRMS into IRMS into cos phi, where phi is what? It is phase difference. So average power is VRMS. VRMS is what? VRMS can be written as V naught by root 2. So V naught in this case is equal to E naught. So E naught by root 2. IRMS is actually I naught by root 2. So we'll calculate the value of average power, which is equal to E naught by root 2 into I naught by root 2 into cos phi. So it is equal to E naught I naught by 2 cos. So what is the average power consumed in one cycle? What is the formula for that? Average power is equal to E naught I naught by 2 cos. And we need to remember this formula because questions are asked directly on this formula. You just have to put values. Okay. They'll give the value of E naught, they'll give the value of I naught, and phi also phase difference. Some cases it is given, other cases I've told you the formulas and situations. Okay, so average power you'll calculate in this. So if we consider the case of resonance, in case of resonance, phi is what? Phi is 0. Okay. Moving on to the next one, we have In an AC circuit with voltage V and current I, the power dissipated. So question number 35. We have an AC circuit with voltage V and current I. We have to calculate the power dissipated. So power dissipated, we just read it in the previous question. Power dissipated is equal to what? It is equal to VRMS into IRMS into cos phi. Okay. So VRMS into IRMS into cos phi. So it is actually V and I in this case is mostly they are constant. So they do not fluctuate much. The power dissipated, it is dependent on the phase difference. So phi is what? Phi is phase difference. So power dissipated is directly proportional to the phase difference. Phase difference between V is voltage and I is current. Okay. And we have read how do we calculate phi. So phi for different cases, I've just explained it here. So phi in case of LR circuit, purely LR circuit, it is 90. In CR cases also it is 90, or it is mostly given in questions. Accordingly, that what is the phase difference? You just have to put the value and we can calculate the power dissipated as, we have written it as VRMS into IRMS into cos phi. So VRMS is V naught by root 2. IRMS is I naught by root 2 into cos. Okay. So this is the equation. And participator depends upon the phase difference. So with this slide and with this question, we are done for the questions for this particular chapter, which was alternating currents. Thank you for listening. Bye bye.